I guess we are live. Are we? Check. Let me 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 check. किधर जाने का? इधर जाने का. Live पे जाने का. Live. I'm live, bro. Wow, freaking crazy. I'll just share my this. If anyone wants to join, I'll just generate this and get a shareable link. Okay, and the link is copied to clipboard, and I'll just post my on Twitter. Crazy, bro. Crazy, bro. Crazy. Your boy is rolling up. I guess we are live. Okay, I'm not tweaking anything. We are live, and you guys must be able to see me fully. Yep. 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 Okay. So, we we did a live stream 1 week ago, but and the agenda was also same that we were we were learning limits and derivatives for the illustrator transformer. Okay, and this is your yeah, this is okay. And but somehow after maybe 5 or 10 minutes of streaming, my internet got off, and that's why we have to do it, shut it down. We have to stop the streaming. But and again, then after that there was 1 week of nothing. But from now, I have considered this as a fact that no matter what, no matter how important how important a work is, but learning 1 hour per day is very crucial for me as I need to go into this direction. Okay, so without wasting and explaining a lot more about this, I have already explained my previous videos in Gen AI Day 2 and Gen AI Day 1. Okay, so I'll just start with this stream. The agenda of this stream is to learn and understand differential equations. Why we are learning differential equations? Because they are the foundational mathematical components that are used in machine learning. How? Because how is that like to be sorry guys, bear with me. I'm just learning to articulate my what's in my mind, but there is a ton of things that are going on right now. But I'll just streamline it. Okay. So why this differential equation, why they are important is because these is the concept that was used for determining the error rate. Okay, so before jumping onto this differential equation, I'll give you a context that in machine learning, everything is based on how we calculate the error rate and then how we can minimize this. Okay, that's how machines learn. Okay, let's say there's a car, Tesla. Okay, it's a machine learning model. Okay, it's based on machine learning model. So when it is on road, say there's a car just ahead of it, and Tesla wants to overtake it. Okay, so it will think it as what is the minimum error rate is there that I don't get, I don't get I don't get rammed into this into this car that is in front of us. So they'll just calculate, okay, calculate the minimum error. Okay, uh I'm not able to properly explain it. Mm, Okay, I'll just I'll just go with the definition that I saw. Okay, no need of improvisation because I won't be able to explain you guys. So consider you are at the top of Mount Everest. Okay, and you don't know what is the path that will lead you to the ground. It's okay. So I'll just show it to you now. Why am I? So this is the okay, this is the Mount Everest. You are right here. Okay, consider this as a 3D. Huh? I'm just making it 2D. So you are right here, right? Now you want to, your end goal is to reach this ground level. So what you'll do is you'll you'll look down and search for possible ways to get down. And the possible ways you found was like you can go from here, you can go from here, and you can go from here. Okay, there are three possible ways. Okay, okay. Now, how you are going to choose between all of this? That is a question. So, what you'll do is ki if what you'll do is ki you'll generate three cases. Case one is if I took this path one, okay, and path one leads to let's say somewhere here. Okay, so your case one will be like this. If I took this path one and reach to its end goal, then what is my distance between to the ground? Okay, let's say after reaching this point in path one, the distance from ground is 60 meter. Okay, now this is case one. For case two, what you'll do is you'll again, and case 2's endpoint will lead you somewhere here. Okay, so you'll again think of some value, think of you'll create a case 2 saying ki what if I took this as a path and reach this goal, then what is the distance between this point and between the ground? Okay, so this point is let's say 70 meters. Okay, so this is your case 2. For case 3, the endpoint is somewhere, let's say here. Okay, so you will create a case 3 that after reaching the case three's endpoint, what is the minimum distance between case three's endpoint and to the ground? And this is some sort of, let's say, 30 meter. Okay, so among all these three, what path you need to, what is the optimal path that you need to take is obviously the third one. Okay, so you'll go here. Okay, so this is a very short example. Let's say the Mount Everest is kind of big, this much. So what you'll do is that again at this point, you'll look out for the ways down. One, two, three. What are the ways? Okay, and then choose the way choose the way in which will give you the minimal or the closest distance to the ground. Let's say this path was giving you 20 meters. This path was giving you 15 meters. This path was giving you 40 meters. This path, but there are chances because it's a mountain. Okay, you don't know. You can always, or the best way you can do is you just jump. My mental health right now. Okay, sorry. Okay, so that is 20 meter, 15 meter, 40 meter. And this path gives you, let's say, 7 meters. Okay, so obviously you're going to take this one. Okay, then again, let's say you've still not reached the ground level. So you'll go there, you'll see ki bhai, what are the possible ways, and then you'll. This is our approach. Okay, anyone who is going down an unexplored mountain or any sort of thing. if you are doing any if you are doing, let's say, uh, doing a thing, okay, for the first time, so this is the most ideal approach one can follow. Ki bhai, what is the how what is the option that is bringing me closest to my outcome, and then you will choose that option. Okay, so that is basically machine learning. Now, now here, this one, two, three, these are very, it is very high level stuff. Okay, in real world, there are tons of calculation. Okay, there are hundreds and thousands of possible ways you can go here. So, going through them, testing them out, and then picking the best optimal solution that brings you closest to the goal point is very, very tough. Okay, so here comes the value of d by dx. This is some sort of it is actually what is telling is he see there were three ways. Okay, there is path one, that is path two, that is path three. Okay, it was basically the, and path one was 70 meter, part two was so path one was 60, part two was 70, and part three was 30 meters. Okay, so what it was telling is कि if I took the path one, the distance between the goal point, end goal, and the ground level was 60 meters. Okay, and I don't know now. Sorry, I'm not being able to understand you guys or explain this because I am not aware. I'm not able to explain you. I do have some concept in my mind, but I'm sorry. I won't be able to explain you further. Yeah, because yeah, that is why I'm learning this. Sorry guys. It was just abrupt, but yeah, I need to do this. Okay, so that is why I do know that where that is the d by dx is used to calculate the error. Okay, and that is why we are going to do all this. Learn differential equations first. What is the actual concept behind them? Okay, okay, okay. So where's the thing? Okay, so to learn differential equation, I have picked up two resources. First is this website. This is crazy website called Math is Fun. These guys are crazy. Okay, they have all of this in order that if you want to learn calculus, you need to go through for limits and derivatives and integrations, and last is differential equations. That is dy by dx or d by dx. Okay, another thing is if you, I see for me, I need something to something that will help me visualize all of this. Okay, so that is why none other than, none other than uh, three blue, one browns video playlist. Okay, we are going through this. We'll go through this, and yeah, I guess we need to start. It's all minutes. Okay, boys, let's start. Just to give you guys a context, I'll be writing stuff what I understood, okay, in this document. I forgot what I wrote was illustrated transformer. Let me just rename this as derivatives, limits, and differential equation. Okay, I'll just create this as a title. Okay, so this is the first part that we're going to tackle. Baki, we also made this We made this take a 1 hour daily 7 to 6 hours. That is, first we'll go for differential equation, then what are deep neural networks, CNNs, RNNs, sequence to sequence models, and this is our goal. What are transformers? Okay, I'll just start now. The art of doing mathematics is finding that special case that contains all the germs of generality. Wow, I don't understand.
The area of the circle into all of these rings times dr, where the specific value
Beautiful. I'll need to stop here. Okay. So what this guy did was, uh, okay, just let me go here. He said that this is the circle. Okay. And we want to, just a heads up, guys. See, um, I know that I have put the end goal as illustrated transformers, but that doesn't mean that I'll just learn only that amount of derivatives or differential equations that are that are good for that are that are sufficient for learning illustrated transformers. No, here with these derivatives and limits, I just want to understand it fully, that it gets into my blood. That is why I'm doing this is so I'll take my time. Okay, no worries. I have no deadline set. Okay, I'll just keep in mind that daily 1 hour I am at this. Okay, so what this guy did was, okay, so we all were taught that, wow. Okay, so we all are taught that the area of a circle is pi r square. Okay, we memorized it. Let's say the point origin is this, and this is r, the radius of circle. Okay, I'm just summarizing this by explaining you guys. So bear with me. So first, if let's say I have given you a task. This is the circle, this is the radius. Give me its area. Okay. And at that time, you don't know this formula. Okay. You don't tell me now that it is by pi r square. No. At that time, think as if, assume that you don't know this formula. Then how you are going to do that? Okay. So what is the, if I want to find an area of a rectangle, then what's the thing? It is kind of, this is length, this is breadth, sorry. Doesn't matter. This is length and this is breadth. Okay. So it is L into B. The area will be L into B. Okay. Let me just search. Area of rectangle. The length into it. Okay. There I'm correct. That is 4 into 3, 12. Okay. But how did this happen? Why? That is important. So what we did is, let's say this is 4 and this is so let's say this is 4 and this is 7. Okay. So what we did was, um yeah, actually we don't know that. Whenever we need to find that, when someone says that find the area of this, then what does he actually mean? Let's say this is the rectangle. Oh, let me just go here. Algebra. The rectangle is for that every angle is 90 degree. The latest plane with a rectangle parameter, that is area. Rectangle area is 6 into 380 meter. Okay, rectangle diagonals called a rectangle. Bro, I don't want this. I'll just search YouTube. Why the area of a rectangle is L. The area of a rectangle is calculated by representing the rectangle on the corner by bounding it between the x-axis and a function. The function can then be integrated between two endpoints to find area. Oh, okay, okay. I'll just write down the questions there. Why is the area of a rectangle is L cross B? So this guy is, he's telling this key, let's say, this is the x-axis. So what he's telling is key, if we put this by representing a rectangle on the corner by bounding it between axis and a function. The area represented on the corner by bounding between the x-axis and a function. The function can then be integrated between two point two. An idea when to choose is f where the constant is the height of the and the endpoints of the indicator. It can be 0 and length of height. Let f of x equals to b on a graph. This looks like the following. Okay, let f of x equals to b. Okay, acha. So what he did was, भाई ये ठीक है यार. This is for I got it. But I need some visualization. Area of circle formula explained. Perimeter. Ah, I need this sort of thing. Yeah. Yeah. Ooh, crazy, bro. This guy is crazy. That is what I wanted. I didn't knew this. Or knew, but I didn't know that. Okay, I maybe I so this is what I wanted is ki what when we are saying when we are saying that I want to find the area of this rectangle. What does we actually mean? Okay, so this guy has simplified this that this is the let's say this is the area, this is the rectangle. The length is I don't know. This is the length. Okay, this is the length is 11. Okay, and this is breadth is 3. Okay, so when I say I want to find, when I say, let's say I'm telling you guys to find the area of this rectangle, then you guys will be L into B, that is 11 into 3, that is 33. You'll do this. Okay, but what do you actually mean? What is this 33? 33 means that 33 means it is a number. It means that 33 number of rectangles whose size, whose length and breadth is 1 meter will get accommodated into this. Okay, इसमें भी see, we are using a reference only. In this universe, everything is derived from some sort of reference. I'll give you a shout out to this, my boy Yupendra. It's maybe we are taking reference of what? Ki of 1 meter. Let's say how many numbers of tile will get accommodated here, which has length and breadth of 1 meter. Okay, so for that I'll just divide this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 1 meter, this is 1 meter, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1 meter. Okay, I'll divide this into three. This is 1 meter and this is 1 meter. Okay, now you can count this. Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So let's say let's say you have a room. Okay, you have a room shaped as this. Okay, whose length you have measured, that is 11 meter, and the breadth is 3 meters. Now 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 I'll tell you that in this room you need to do a flooring. Okay, and you need to do flooring such that each tile is 1 meter. Okay, then how many number of tiles it will be required? Answer is 33. Whoa! Crazy. This guy is crazy. This guy is freaking crazy. Okay. So when I'm telling this, coming back to our circle, okay, coming back to our circle, let's say this is the circle. This is the circle, right? When I'm telling you is I want to find the area of this circle. Then in a way, I'm telling you to tell me how many number of tiles will be will get placed inside this. Okay, obviously it is circle, so you won't get any absolute 33 or 34. There will be a decimal values. But to look at as someone, to look at it as a to look it as, sorry, I'll just rephrase it. You need to imagine you have one meters of small cubes. You got it what with yourself. So whenever, let's say, someone is asking you ki, hey Yash, this is I want the area of this. Okay, tell me the area of this. So obviously you are not going to tell him. How can you tell? You are not able to tell this without the reference. You can always tell this by telling him that I don't know, but I have this one cube, okay, 1 meter cubes, which I can place, and I'll tell you that how many number of cubes will it get, will it how many number of cubes will be stored in this area, and from that you can get an idea, because ultimately why we are using area, okay, we just why because it is giving our mind the perspective of size. Okay, let's say the area of this one, and this one. Why do I want to why do I want to uh, let me just rephrase it again. Okay, let's say why first of all, at the very first point, why do I need to get the notion of which is bigger? Because see, obviously this is bigger, I can see it, but mathematical wise, or someone who is blind, I'm not going dark, but yeah, let's say I'm blind, okay, and I don't know, I can just hear someone, okay. So to deduce which one is larger, I'll need something. No, I need something as a metric or as a number that will give me the idea. Okay, hey, this pillow is larger. Okay, so I'll let's take this example only. This is the pillow, okay, and I'm asking you to find the area of it. So what you'll do is you'll think you just think that you have uncountable 1 meter cubes with you. What you'll do is you'll start placing them one by one. So and up till now, up till to this point, okay, you have put all the cubes in a very meticulous manner, as precise as it can be, and you have put it right till here. And then you'll come to me and say, okay, hey, yes, this is the number of 1 meter cubes, that total number of 1 meter cubes that can be placed inside this is, let's say, 100. Okay, I got an idea. I got an idea ki what, how much, how much cubes this pillow or this surface can accommodate. Okay, then I'll again ask you. Okay, this is good. Okay, Now tell me the area, or tell me how much cubes it can this surface can accommodate. You'll again place that, you'll again have this 1 meter cubes with you. Okay, you'll again start placing with start placing them. Okay, you have reached here. You come and you tell that, hey Yash, the total number of cubes here is 250. Okay, so in a way, my mind got something to compare. What? That the cubes were same, 1 meter and 1 meter, but why 250 were placed here in this surface? Because it has obviously much larger surface area compared to this guy. Okay, so whenever I this guy I myself got this understanding of that whenever, let's say, someone asks you that give me the area, he's indirectly telling you that how many number of 1 meter cubes this area can accommodate in it, for rectangles or for squares. Okay, but what I think is, he's this is applicable to all the shapes. Let's say I'll just tell you guys. Let's say this is the 1 meter cube. Okay, I'll just I can have an approximation, right, like this. Okay, but why it for circles it would be tough. Why? Because I'll just group this guys. If yo, what the heck, bro? Search term image distribution. Ah, okay. I can paste all this. Okay, but somehow at the very end I won't be able to get this the accurate answer, because it's not rectangle, it's not square. Okay, let's say I'll okay, I won't be able to find the area. Okay, I'll just precisely, some of you guys might be think, oh, it can be placed here and all. Okay, let's say it is placed here. Hey, okay, okay. So these are placed here. But what about this? Let's say यहाँ पे तो भी 1 meter in this space, if I try to accommodate, it won't get. But what about this space? So anyways, you are not going to get uh, accurate results. This method is perfect. Obviously, if I tell you that, let's say, erase that pi r square formula. Okay, if I tell you that find me the area of circle, and you use this same approach. Okay, you start putting this 1 meter square, 1 meter cubes inside it. Okay, you'll be able to tell me. Okay, let's say the area, let's say uh, there's a circle of only one radius. Okay, just I'm giving you for an example. Let's say there's a circle for of only one radius. Okay, so what will be its area? That is pi r square, that is 3.14. Okay, this is precise. Now if you have, let's say this is the first approach you took, you just multiplied it, this is 3.14. Now what if you took this approach? You will be kind of close to 3. I'm not telling you it is 3.1 exact, or maybe 2.5, above 2.5. That, hey, yes, in this circle, exactly I can place 1 meter. Sorry, exactly I can place uh, two cubes, two cubes which has 1 meter in their sides. So that is kind of close. That is kind of close now. Let's say I'll just, where's my data? Okay. I'll just take this. This is 1 meter, and this was also 1 meter. Okay, let's consider this only. For you guys, I'll just narrow it down. Okay, so that only this is 1 meter, kind of we can say. Okay, so what you can tell is, okay, hey, yes, this is actually we can place two cubes we can place easily. But I don't know about but even despite of placing them very particularly, very precisely, there are spaces like this, there are voids which are not filled, and I'm not able to get the answer of it. Okay, so this approach will lead you closer to the outcome, lead you closer to the result, but it is not precise in terms of circle. Okay, so for circle, again, what this guy has done is, if you see for rectangles, let's say this was the rectangle, right? This was the rectangle. What we did here was, we chopped it down in a very precise manner that we get 1 meter cubes, 1 meter cube rectangles, 1 meter cube squares, doesn't matter. Okay, we chopped it down in a very precise manner that we get 1 meter cube, 1 meter cube. What the heck? 1 meter cube rectangles. Okay. So if we follow the same approach, let's say for this circle, this is the circle. Okay. Now if I just start creating smaller and smaller radius circles inside this, like this. Okay. But can I do that with one radius? Okay. Let's say the radius of this is this. No, but still it will, yeah. So if we follow this approach strictly, then we won't be doing this. We should be doing this sort of circles, right? Okay, this sort of thing. But still, okay, that I don't know why we didn't took this. But I got this thing of, I'll just tell right here is, when someone asks you what is the area of a rectangle, he is actually asking you the number of 1 meter, 1 cross 1 meter, 1 meter rectangles that can fit in it. Okay, so this is quite done. This guy is crazy. Yep. Ooh. Okay. So this is again a rectangle. Okay. And to find this rectangle, what we are actually telling you, how many number of tiles of 1 cross 1 can fit in this? Can fit in this rectangle where the length is x squared and breadth was px. Crazy. Crazy, bro. So I guess that's it. We have done 1 hour of 1 hour of learning. We do get to know that when someone says that find me the area of some surface, what does he actually means? Okay. Again, for derivatives, at the last part, we kind of understand and we do not understand. What he said was it was x square. The length was x square. Okay. Let's say this is the graph. Okay. So what he said was, let's say this is x at some point. Okay. And this is x square. Okay. Y. Y equals to x square. If I remember some x plus over x plus 0.0, then dx will be this. Okay, so if I know, then this will be dx. So the area of this will be x square into dx. Area is divided d of area. अच्छा. Okay. ठीक है. I kind of got to know something. Okay. Okay, guys, that's it. I'll just I'll meet you guys tomorrow, and tomorrow we'll start with the next video of what does actually derivatives mean. Uh, yeah. Thank you so much, boys. Thank you so much. Bye.